Today let's look at derivatives of inverse functions. So let's begin with this theorem. Let f be a function which is differentiable on an interval capital I. If f has an inverse function little g, then little g is differentiable at any x for which f prime of g of x is not equal to 0. Moreover, g prime of x is equal to 1 over f prime of g of x, where f prime of g of x is not 0. So this allows us to calculate the derivative of an inverse function without actually calculating what that inverse function is. For example, let's look at f of x equals x squared plus x plus 1. Observe that f of 3, for example, is equal to 13. Now suppose we wanted to find the inverse function, the inverse function's derivative at 13. The theorem above tells us that f inverse prime of x is 1 over f prime of f inverse of x. Thus, since f of 3 is 13, we know f inverse of 13 is 3, so that f inverse prime of 13 is 1 over f prime of f inverse of 13. But we know f inverse of 13 is 3, so we just need to compute f prime of 3. A quick calculation shows, starting with f of x equals x squared plus x plus 1, f prime of x equals 2x plus 1, and f prime of 3 gives us 2 times 3 plus 1 equals 7. Therefore, the derivative of f inverse at 13 is 1/7. So what we have just shown is that given f of x equals x squared plus x plus 1, we have the derivative of f inverse at 13 is 1/7. Notice we found the derivative of the inverse function at 13 without calculating f inverse explicitly. This is very interesting and very useful.